Hey guys, this is Mrs. Gebhardt, and these are the water property notes. The essential questions that you need to make sure you can answer at the end of this are, what are the properties of water, and then what are some of water's unique characteristics? First property of water is adhesion, and adhesion is just water's tendency to be attracted to other things. So it's like the word adhesive. It just means that it is able to stick to other things like spider webs, or like we can see here, it's kind of stuck to blades of grass. That's adhesion. The next property is cohesion, and cohesion and adhesion go really well together. Cohesion is water's ability to be attracted to itself. So when it's attracted to itself, it sort of forms this sphere shape, like we can see in the way that it's sticking to the spider web. And here's a little smiley face. But the fact that it's sticking in a sphere shape is cohesion, and the fact that all of these droplets are stuck on this spider web is adhesion. Next we have buoyancy, and buoyancy is simply a force that pushes upward on an object, especially when we're thinking of water. We know that gravity is pushing downward, so buoyancy is the force pushing upward. It's allowing this dude right here to kind of hang out in the water. It's allowing this ship to be sitting above the water, or not necessarily above the water, but being pushed up in the water where it's not sinking. Another example is an iceberg floating in Antarctica, and buoyancy will very much depend on the type of water. So salt or fresh water will depend on how buoyant something is. Capillary action is another property of water, and all this simply means is that it's the ability of a liquid, in our case it's water, its ability to rise against gravity in a small tube. And when we think about a small tube, I want you to envision a plant. So the ability for a plant to go from its roots and pull water all the way up to the very tippy top. And in this example, we can see this is the blue dyed water, and when we submerge this leaf from lettuce into the water, we can see that the blue is traveling upward, and that's just showing capillary action. Next we have density, and density is simply the amount of mass in a given volume. And we will get back into calculating density, but that is the equation. So density equals mass divided by volume. An example is if I throw a rock into water, it will sink because it's denser than the water. But if I put an ice cube in, it will float because it's less dense. So if we look over here at this cup, we have all these different liquids that have been put into this cup, and they have divided themselves based on their density. So honey is the most dense, and it's sunk to the bottom. Next we have the corn syrup, followed by the dish soap. We have some water that's been dyed red, and then finally vegetable oil, which would be the least dense. Polarity is simply water's ability to be attracted to other things. It's because water is a molecule that has these positive and negative ends, and it kind of like a magnet. It just is able to really get along well with a lot of other things. So an example that I thought of is if we take Kool-Aid mix and we mix it in with water, it comes out to be this wonderfully fruity, refreshing beverage. And as we can see right here, we've got the Kool-Aid. It's the same from the top to the bottom. It's the same from one side to the other, and it's uniform throughout. So that's just showing water's ability to sort of dissolve other things and be attracted to them to be able to dissolve them. Surface tension is the measurement of the strength of the surface of the water. So if we look at this cup, that's the surface, and it's sort of pulled very tightly, almost like if you were pulling a blanket, so very tightly. And in this example, it's actually holding a yen, and it's made of aluminum. Otherwise, in any other circumstance, this coin should sink because it's more dense in the water. But if we can keep that cup very still, we're able to sort of lay the coin on top. Another example is when we see bugs sort of just chilling out on the water, walking across the water. If we see a leaf hanging out on top of the water, anything like that, it's because of water's surface tension. Water is considered a universal solvent, and it's a universal solvent because of its polarity, which means it's able to dissolve most substances on the planet. That's what makes it a universal solvent. That's something very important that you're going to need to remember. Examples include water dissolves sugar, water dissolves salt. Water, when we make sweet tea, it's made of water and we have the tea, and if we want to make it sweet, we then dissolve the sugar. In this example over here, we've got coffee, which is water-based, and we've got sugar being dissolved into it. So universal solvent means that water, because water is so polar and attracted to so many things, it's able to dissolve so many things. So just recapping our essential questions, making sure that we are able to sort of talk about the properties of water, and that you're able to, with confidence, mention water's unique characteristics. If you can't answer those 8 properties and what they are and examples of them, you need to rewind this and go back through it and review what those properties are and ask questions for your teacher when you see them in class.